Thunderstorms are among nature's most dramatic displays, captivating us with their booming thunder and brilliant flashes of lightning. But what really causes these powerful storms? In this video, we'll journey into the heart of a thunderstorm, exploring the science behind their formation, the secrets hidden within the clouds, and the incredible forces at play. Whether you've watched storms from your window or experienced their intensity up close, understanding their mysteries can deepen your appreciation for the natural world. Let's begin by uncovering what exactly a thunderstorm is and why it's so much more than just rain and thunder. Thunderstorm is defined by the presence of thunder and lightning, usually accompanied by heavy rain, gusty winds, and sometimes hail. These storms can occur anywhere in the world, but they're most common in warm, humid regions. The key ingredient is moisture in the air, which rises and cools, forming towering clouds. As the storm develops, electrical charges build up, setting the stage for lightning. But what triggers this process, and how does it all come together? Let's take a closer look at the essential elements that create a thunderstorm. Warm air plays a crucial role in the birth of a thunderstorm. When the sun heats the ground, the air near the surface warms up and begins to rise. This rising air carries moisture with it, and as it ascends, it cools and condenses into clouds. The process continues, building larger and larger clouds until they tower high into the atmosphere. This upward movement of warm, moist air is the engine that drives thunderstorm development. Without it, the dramatic displays we associate with storms simply wouldn't happen. As warm, moist air rises, it cools, and the water vapor within it begins to condense into tiny droplets. These droplets cluster together, forming the familiar fluffy shapes of cumulus clouds. When conditions are just right, these clouds grow rapidly, reaching heights of several kilometers. The tops of these clouds can even flatten out, creating the classic anvil shape seen in powerful thunderstorms. This process marks the beginning of a storm's life cycle and sets the stage for the dramatic events to follow. Drafts are strong currents of rising air that fuel the growth of thunderstorm clouds. As more warm air is drawn upward, the storm intensifies and the cloud continues to expand. These updrafts can be so powerful that they lift water droplets and ice particles high into the atmosphere where temperatures are much colder. This movement is essential for the development of hail and for the separation of electrical charges within the cloud, both of which are key to the storm's most dramatic features. While updrafts carry air upward, downdrafts bring it back down. As rain forms within the cloud, it becomes heavy and begins to fall, dragging cooler air with it. This creates a downdraft, which can lead to sudden gusts of wind at the surface. The combination of updrafts and downdrafts creates the turbulent churning motion inside a thunderstorm, resulting in heavy rainfall and sometimes even hail. These powerful air movements are what make thunderstorms so dynamic and unpredictable. Lightning is one of the most awe-inspiring aspects of a thunderstorm. It occurs when electrical charges build up within the cloud and eventually discharge, creating a sudden powerful flash of light. These discharges can travel between clouds, within a single cloud, or from the cloud to the ground. The intense heat from lightning can reach temperatures hotter than the surface of the sun, causing the air to expand rapidly and produce the sound we know as thunder. But how do these electrical charges form in the first place? Inside a thunderstorm cloud, tiny ice particles and water droplets collide as they're carried by updrafts and downdrafts. These collisions cause electrons to be stripped from some particles and transferred to others, creating regions of positive and negative charge within the cloud. Typically, the top of the cloud becomes positively charged, while the bottom becomes negatively charged. This separation of charges is what sets the stage for lightning to occur, as nature seeks to balance the electrical difference. The difference in electrical charge between the cloud and the ground, or within the cloud itself, becomes too great, a lightning bolt is unleashed. The process begins with a faint, invisible channel of ionized air called a step leader, which moves downward from the cloud. When it nears the ground, a surge of positive charge rises to meet it, completing the circuit and creating the brilliant flash we see as lightning. This entire process happens in a fraction of a second, but its effects are unforgettable. Thunder is the sound produced by the rapid expansion of air heated by a lightning bolt. When lightning strikes, it heats the air to thousands of degrees in an instant. This sudden heating causes the air to expand explosively, creating a shock wave that travels outward as sound. That's why you see lightning before you hear thunder. The light travels much faster than sound. The rumbling or cracking noise can vary depending on your distance from the strike and the landscape around you. Not all thunderstorms are the same. Some are brief and isolated, while others can last for hours and cover large areas. The main types include single-cell storms, which are short-lived and usually mild, multi-cell storms, which contain several storm cells and can produce heavy rain and hail, and supercell storms, which are the most powerful and can spawn tornadoes. Each type has unique characteristics, but all share the same basic ingredients: moisture, rising air, and instability. Supercell thunderstorms are the giants of the storm world. They feature a rotating updraft called a mesocyclone, which gives them their distinctive structure and incredible power. Supercells can produce extremely large hail, intense winds, and even tornadoes. Their rotation is caused by wind shear changes in wind speed and direction with height. These storms are rare, but are responsible for some of the most severe weather events on the planet. Thunderstorm goes through several stages in its life cycle. It begins with the cumulus stage, where updrafts build the cloud. Next is the mature stage, when the storm is at its most intense with heavy rain, lightning, and thunder. Finally, the dissipating stage occurs as downdrafts dominate, cutting off the storm's energy supply and causing it to weaken. Understanding this cycle helps meteorologists predict how storms will develop and when they might pose a threat. Hail is a common feature of strong thunderstorms. It forms when updrafts carry raindrops into extremely cold areas of the cloud where they freeze. As these ice pellets are lifted and dropped repeatedly by the storm's winds, they grow larger, adding new layers of ice each time. Eventually, they become too heavy to be supported and fall to the ground as hailstones. Some hailstones can reach impressive sizes, causing damage to crops, vehicles, and buildings. Thunderstorms often produce strong winds, especially at the leading edge of the storm. This area, known as the gust front, forms when cool air from downdrafts spreads out along the ground, lifting warm air ahead of the storm. Gust fronts can create dramatic changes in wind speed and direction, sometimes causing dust storms or sudden temperature drops. These winds can be powerful enough to knock down trees and power lines, making them a significant hazard. One of the most dangerous aspects of thunderstorms is their ability to produce flash floods. When heavy rain falls in a short period, the ground can't absorb it quickly enough, leading to rapid flooding. Low-lying areas, urban environments, and places near rivers are especially at risk. Flash floods can develop with little warning, sweeping away vehicles and causing significant damage. It's important to stay alert during storms and avoid flooded roads. One of the most severe thunderstorms can produce tornadoes, violent rotating columns of air that extend from the cloud to the ground. Tornadoes form when wind shear and strong updrafts combine to create a spinning effect within the storm. While not all thunderstorms produce tornadoes, those that do can cause devastating damage in a matter of minutes. Meteorologists use radar and other tools to track these storms and issue warnings when conditions are right for tornado formation. Thunderstorms can be beautiful, but they're also dangerous. It's important to stay indoors during a storm, away from windows and electrical appliances. Avoid using phones or plumbing, as lightning can travel through wires and pipes. If you're caught outside, seek shelter in a sturdy building or vehicle. Stay away from tall objects, open fields, and bodies of water. Being prepared and knowing what to do can help keep you safe when storms strike. Thunderstorms are a global phenomenon, occurring on every continent except Antarctica. They play a vital role in Earth's climate by redistributing heat and moisture around the planet. In some regions, storms bring much-needed rain, while in others, they can cause destruction. Understanding how thunderstorms fit into the larger picture of weather and climate helps us appreciate their importance and the need for ongoing research. For farmers, thunderstorms can be both a blessing and a curse. On one hand, they provide essential rainfall that helps crops grow. On the other, they can bring hail, strong winds, and flooding that damage fields and reduce yields. Understanding storm patterns allows farmers to better prepare and protect their crops. Advances in weather forecasting have made it easier to anticipate storms and take action to minimize losses. Cities face unique challenges during thunderstorms. Urban areas are prone to flash flooding due to large amounts of concrete and limited drainage. Lightning can disrupt power supplies and damage infrastructure. Emergency services must be prepared to respond quickly to accidents, fires, and other hazards caused by severe weather. Urban planning and improved drainage systems are key to reducing the risks posed by thunderstorms in city environment. Storm chasers are scientists and enthusiasts who track thunderstorms to study their behavior and gather data. By getting close to storms, they can collect valuable information about wind speeds, rainfall, and lightning activity. This research helps improve weather forecasting and our understanding of severe weather. While storm chasing can be dangerous, it has led to important discoveries that benefit society as a whole. Radar technology is essential for tracking thunderstorms. By sending out radio waves and measuring their reflections, radar can detect rain, hail, and even tornadoes within a storm. Meteorologists use radar images to monitor storm development, issue warnings, and keep the public informed. Advances in radar technology have made it possible to predict severe weather with greater accuracy, saving lives and property. Lightning detection networks use sensors spread across large areas to pinpoint where lightning strikes occur. These systems help meteorologists track storm intensity and movement in real time. By analyzing lightning data, scientists can better understand storm behavior and issue timely warnings. Lightning detection is also important for aviation and outdoor event planning, helping to keep people safe during severe weather. Their satellites orbit high above the Earth, providing a bird's-eye view of thunderstorms and other weather systems. They capture images and data that help meteorologists track storm development, measure cloud heights, and monitor lightning activity. Satellite technology has revolutionized our ability to forecast storms and respond to severe weather events, making it an essential tool for modern meteorology. Climate change is affecting thunderstorms in many parts of the world. Warmer temperatures mean more moisture in the air, which can lead to more frequent and intense storms. Scientists are studying how changing weather patterns might increase the risk of severe weather, including heavier rainfall, stronger winds, and more lightning. Understanding these trends is crucial for preparing communities and adapting to a changing climate. Thunderstorms aren't unique to Earth. Scientists have observed storm activity on other planets, such as Jupiter and Saturn, where lightning and massive cloud systems are common. These extraterrestrial storms are much larger and more powerful than those on Earth, offering fascinating insights into the dynamics of planetary atmospheres. Studying storms on other worlds helps us understand the universal forces that shape weather throughout the solar system. Animals often sense thunderstorms before humans do. Many species can detect changes in air pressure, humidity, and even the electrical field generated by approaching storms. Birds may seek shelter, while dogs and cats can become anxious. Understanding how animals respond to storms can provide early warning signs and help us appreciate the deep connections between living creatures and the natural world. Throughout history, thunderstorms have inspired myths and legends in cultures around the world. Some saw them as the anger of the gods, while others believed they were messages from the spirit world. These stories reflect humanity's awe and respect for the power of nature. Today, science helps us understand the true causes of storms, but the sense of wonder remains as strong as ever. Capturing the beauty of thunderstorms is a passion for many photographers. Lightning, dramatic clouds, and rainbows create stunning visual effects. Photographing storms requires patience, skill, and a keen eye for safety. The resulting images not only showcase nature's power but also inspire others to appreciate the wonders of the weather. Storm photography has become a popular way to connect with the natural world and share its beauty. Thunderstorms can evoke a wide range of emotions, from excitement and awe to fear and anxiety. The sound of thunder and the flash of lightning can trigger memories and feelings, reminding us of nature's power and unpredictability. For some, storms are a source of inspiration, while for others, they bring unease. Understanding our emotional responses to storms can help us cope with their impact and find meaning in their presence. For children, thunderstorms can be both fascinating and frightening. Parents can help by explaining what causes storms and reassuring kids that they're safe indoors. Watching storms together can be an opportunity to learn about science and the natural world. Encouraging curiosity and providing comfort can turn a scary experience into a memorable and educational one. Being prepared for thunderstorms is essential, especially in areas where severe weather is common. This means having an emergency kit, knowing where to take shelter, and staying informed through weather alerts. Practicing safety drills and having a family plan can make a big difference when storms strike. Preparation helps reduce anxiety and ensures everyone knows what to do in an emergency. After a thunderstorm passes, the sun often shines through lingering raindrops, creating a rainbow. This beautiful phenomenon occurs when sunlight is refracted, reflected, and dispersed by water droplets in the air. Rainbows are a reminder of the wonder and beauty that can follow even the most intense storms. They symbolize hope and the promise of calm after the chaos. Thunderstorms often cause power outages by knocking down trees and power lines with strong winds or lightning strikes. Being prepared with flashlights, batteries, and backup power sources can help you stay safe and comfortable during an outage. It's also important to avoid downed power lines and report them to authorities. Quick action and preparation can minimize the inconvenience and danger of losing electricity during a storm. Thunderstorms pose significant challenges for pilots and air traffic controllers. Turbulence, lightning, and strong winds can make flying dangerous. Modern aircraft are equipped with weather radar and other tools to detect and avoid storms, but delays and diversions are sometimes necessary for safety. Understanding how storms affect aviation helps keep passengers and crews safe in the skies. Severe thunderstorms can disrupt communication networks, including cell phones, internet, and radio. Lightning strikes and strong winds can damage towers and cables, making it difficult to stay in touch during emergencies. Having backup communication methods such as battery-powered radios is important for staying informed and connected when storms hit. Planning outdoor events during thunderstorm season requires extra caution. Organizers should monitor weather forecasts, have contingency plans, and be ready to move people to safety if storms approach. Lightning is especially dangerous in open areas, so quick action is essential. Being prepared ensures that everyone can enjoy the event safely, even if the weather takes a turn for the worse. Thunderstorms pose special risks near water. Lightning can strike lakes, rivers, and pools, making swimming or boating extremely dangerous during a storm. If you're on or near water when a storm approaches, get to shore and seek shelter immediately. Water safety is crucial as storms can develop quickly and catch people off guard. Forests are often affected by thunderstorms, which can bring much-needed rain but also cause damage through high winds and lightning-induced fires. Fallen trees and branches can block trails and roads, while fires can threaten wildlife and habitats. Forest managers monitor weather conditions closely and take steps to reduce the risks posed by severe storms. Some people, thunderstorms can trigger anxiety or stress, especially if they've experienced severe storms in the past. Practicing relaxation techniques, staying informed, and having a plan can help manage these feelings. Talking about your concerns with friends or professionals can also provide support. Remember, it's normal to feel uneasy during storms, and taking steps to stay safe can ease your mind. Thunderstorms remind us of the incredible power and unpredictability of nature. Their energy can be both destructive and life-giving, shaping landscapes and ecosystems. By studying storms, we gain a deeper respect for the forces that govern our world and learn how to live in harmony with them. The next time you hear thunder, remember the secrets hidden within the storm. Advances in technology are opening new frontiers in storm research. High-resolution computer models, drones, and improved sensors are helping scientists understand storms in greater detail than ever before. This knowledge leads to better forecasts, improved safety, and a deeper appreciation for the complexity of weather. The future holds exciting possibilities for unlocking even more secrets of thunderstorms. Thunderstorms can impact renewable energy sources like wind and solar power. High winds can damage turbines, while heavy clouds reduce solar output. However, storms also highlight the need for resilient energy systems that can withstand extreme weather. Engineers are developing new technologies to make renewable energy more reliable, even during the wildest storms. Thunderstorms are a powerful reminder of nature's complexity and beauty. By understanding the science behind them, we can better appreciate their role in our world and learn how to stay safe when they appear. From the first rumble of thunder to the last drop of rain, storms invite us to marvel at the forces that shape our planet. As we continue to unlock their secrets, we deepen our connection to the natural world and the mysteries it holds.